This is the LG UltraGear Evo 27GM950B, the company's new 27-inch 5K resolution mini LED monitor. We first saw this one at CES in January and it's now starting to appear on the market. Lots of you have been asking about this one and we'll review it in full here and tell you all about its top-end features and specs. It's an IPS LCD screen with a 5120 by 2880 5K resolution and 218 ppi, which provides a super sharp and clear image and a Retina class pixel density on a screen this size. This makes it ideally suited to both Windows and Mac users. It's got a native 165Hz refresh rate and also a dual mode function which supports a faster 330Hz at a lower 1440p resolution. Still a very viable and comfortable resolution on a 27-inch screen like this. This is part of a new wave of 5K dual mode monitors that we're seeing released to market, offering a killer combination of amazing visuals for work and general use and a high refresh rate for gaming when you need it. The other key highlight here is the 2304 zone Hyper Mini LED backlight, offering twice the number of dimming zones than competing mini LED monitors that we've typically seen. This gives you even better contrast control and potentially improved HDR experience. It's certified under the VESA Display HDR 1000 tier and it's promoted as offering a zero optical distance engineering, which brings the backlight closer to the panel and it's supposed to help minimize light bleed, blooming and halos. The screen also features LG's latest AI capabilities that we've seen on some of their other recent UltraGear Evo lineup, and we'll take another look at those later on as well, including the 5K AI Upscaling support. Anyway, those are the key specs. Let's get into all of our testing and start by looking at the brightness and the so-called Hyper Mini LED backlight. The screen offers an impressive luminance adjustment range, reaching up to a very bright 748 nits maximum in SDR, which meets the advertised spec nicely. There's also a good minimum luminance range for working in darker room conditions if you need it. Since this is an IPS LCD panel, contrast ratio is modest at around 1000 to 1 average, which meets the advertised spec but falls behind some other modern IPS black panels, which can reach up to 2000 or maybe 3000 to 1 nowadays, and also of course behind VA LCD panels, which can reach up to around 4000 to 1 in some cases. In SDR mode, contrast and black depth are a weakness of the IPS panel here. However, this can be improved significantly in dynamic content for gaming and multimedia when you're using the local dimming option, which LG allow you to use even in SDR mode. There's 3 settings available and you can see that all of them offer massive improvements in overall scene contrast potential. There's some minor improvements as you move up from the settings, but they all remain pretty similar in absolute SDR brightness and contrast, and in real-world content there was very little difference of note. All of them will dim the brightness by a similar amount for small bright areas to help reduce the risks of blooming and halos, which is standard behaviour on mini LED monitors, and again they're all very similar to one another in that scenario. The local dimming setting could be useful for dynamic SDR content to significantly improve black depth and contrast, but we wouldn't recommend using it for static applications or desktop use. Just leave it off for those uses. Let's look at HDR performance here as well, and we'll come back to SDR usage in more detail later on. One of the key features of this new screen is the so-called Hyper Mini LED backlight, offering twice the number of local dimming zones than you'd commonly find on high-end mini LED monitors in the market. There's 2,304 local dimming zones here, with 9,216 total LEDs, so that's 4 per dimming zone, offering tighter control over dimming and brightening of the image thanks to the higher zone count. One of the features promoted for the new panel and the backlight combination is the zero optical distance engineering, which apparently brings the backlight closer to the panel and helps reduce light bleed, halos and blooming, something that we'll look at more in a moment. There's a selection of HDR preset modes available in the game menu, which have the same default configuration combinations that we'd seen on LG's other recently reviewed screens, like for instance their 39-inch ultra-wide OLED monitor as well. The Gamer 1 mode is the one that's certified under the VESA Display HDR scheme according to the menu, and in all of the modes the local dimming is set to high by default, although you can change that if you want to. You can configure the brightness control and the color temperature mode as well in HDR if you want to make tweaks. Peak white luminance reached up to just over 1000 nits in our measurements, meeting the requirements for the VESA Display HDR 1000 tier that the screen is certified under, but not reaching the 1250 nits spec for some reason. We tried various input sources, modes, and combinations of settings, and we couldn't reach anything brighter on our unit, leaving it around 250 nits short of the advertised spec. The brightness behaviour in HDR is unusual for a mini LED, as it seems to be capped across all scenes at around 1000 nits maximum. Typically, we see mini LED screens able to push maximum luminance even higher in many situations, as you can see here with a comparison against two other recently reviewed 27-inch mini LED monitors. Keep in mind that it's only the potential maximum white luminance that we're talking about here that the backlight can push. Whether or not you'd ever see content mastered to those levels and then realise those kind of brightness levels in real use is another question entirely. We'll also need to consider other performance areas such as contrast and blooming levels. The EOTF tracking in HDR remains pretty consistent regardless of the overall scene brightness and APL, and also the size of the measurement window that we're using. Here's the results in the default Gamer 1 mode, but we saw the exact same thing in all of the other HDR modes as well, in any mode where the dynamic tone mapping function was disabled, which was most of them. The preset mode and the local dimming mode don't seem to make a difference to the EOTF tracking, it seems. In this default configuration, the luminance, represented by the grey line on the graph, is a little bit below the yellow target line, meaning that the luminance is lower than intended, which makes the image a little bit darker than it should be. We just referenced it a minute ago, but LG also provide an option called Dynamic Tone Map in the menu, which increases overall HDR brightness noticeably. Although this does result in the luminance being higher now than intended in dark and mid shades, and then a bit more of a noticeable roll-off is also introduced in brighter scenes, which reduces the luminance a little bit of lighter shades. The dynamic tone map mode leads to some moderate crushing of brighter details, so there's a choice really here between a mode which is a bit darker but retains some additional detail, and another that's brighter but loses some detail. Although at least on this screen, the dynamic tone map function doesn't over-brighten the screen as drastically as we saw on their 39-inch OLED monitor recently, which had made that mode pretty much unusable in that instance. Brightness differences in real-world content between off and on modes are noticeable, and we think that most people will prefer the brighter experience with dynamic tone map turned on for a more impactful HDR experience. We saw on average a 71% higher luminance in real scene HDR content with dynamic tone map turned on. Compared to some other recently tested mini LED monitors, we already compared the peak white luminance measurements earlier. In side-by-side testing, the KTC M27P6 was very similar in overall brightness, but the Kirui S2741LM was brighter in some situations, and you can see that reflected here in these measurements as well. However, while the Kirui model has been optimized for brightness, the LG model has been optimized for contrast, and you get deeper blacks and better overall contrast and reduced halos and blooming as well. The Kirui model was actually already pretty decent in blooming compared with some other models that we've tested, but the LG takes things a step further, and you get far less noticeable halos in real-world usage. This is especially apparent when viewing dark content from an angle like in these tests, where IPS panels normally struggle quite a lot, but this new LG screen does much better in these tests. Blooming is significantly reduced and contrast is better as well. Obviously, it's unlikely that you'd ever be using the screen from such an extreme viewing angle, but it does show how the panel has been optimized for contrast and how the zero optical distance engineering has seemingly helped quite a lot with the blooming levels in practice. It makes it more suitable for viewing from different angles than just a head-on viewing position if you need to, as well as dark scenes where small highlights are dimmed more efficiently. As we've seen on some other mini LED monitors in the past, the color temperature varies a little bit depending on the size of the measurement area, with smaller areas in the low APL dark scenes being a little bit cooler than the larger areas in brighter scenes. This seems to be a feature of mini LED monitors, but the difference is very minimal actually on this LG screen, and in real content it's very hard to spot any variation at all, which is great news. Shadow detail was poor in HDR mode, unfortunately, especially if you disable the dynamic tone map option, although we'd recommend leaving that on for a brighter experience. With it turned on, the first visible grey shade was RGB 7. This dropped to RGB 12 if you turn dynamic tone map off. You do still have access to the black stabilizer setting in HDR, which is useful as it can brighten darker scenes and darker content quite well, and that's all without raising the black point at all. Moving this up to a maximum setting of 100 brought out some additional dark grey shadow detail, and we could now see RGB 4, although that's probably a little bit extreme as it raises some other shades a bit too much. This is one to experiment with in darker content if needed. The screen operates with its full native colour space in HDR mode, reaching an impressive 89% coverage of the Rec 2020 colour space and offering very vivid and saturated colours. And there was also very good overall colour accuracy in HDR mode as well, which was pleasing. Moving back to SDR performance again, and we'll look at the accuracy out of the box. The screen comes in the Gamer 1 mode by default, which offers a very good gamma accuracy and decent grayscale, weighted a little bit towards red and being a little bit too warm in light shades, but not by anything significant. This screen has an extremely wide colour gamut, I think actually the widest that we've seen in fact so far, extending up to 156% relative coverage of sRGB, with massive oversaturation in red and green shades especially. Colours look very vivid and saturated, but this can lead to large errors in SDR content that's designed for the smaller sRGB colour space, so accuracy for that content was very poor. That's normal though for any wide gamut monitor, and we'll look at ways that this can be improved in a moment. There's full coverage available for both the DCI-P3 and Adobe RGB colour spaces, although there's still a lot of overcoverage natively, leading to better but still poor colours for DCI-P3 content in the native mode. LG provide an sRGB emulation mode in the menu as well for more accurately working with SDR and sRGB content. It has a lower default brightness and some of the settings are now locked, but you still have access to adjust the brightness to your preference, along with access to the contrast and the RGB channels, which is good news. Gamma and grayscale remained good as before, with some minor improvements in the grayscale accuracy. We did notice a small drop in the contrast ratio in this mode, but it remained close to the 1000:1 spec. The main change in this mode is the clamping of the very wide native gamut back to the sRGB reference space, which was nice and accurate, and this resulted in drastically improved sRGB colour accuracy. This mode is very useful for working more accurately with SDR content. There's also a DCI-P3 mode available in the menu, although this one is configured to a higher 2.6 gamma, which is the standard for the DCI-P3 Theatre standard. The colour temp is quite noticeably warmer though, with the blue channel not nearly as high as it should be, and this reaches a white point of around 5700K, which doesn't align with any of the specific targets for the DCI-P3 Theatre, so we can only assume this is down to poor factory calibration in this mode. Again, one of the main changes in this mode is the clamping of the native colour space back closer to DCI-P3. It's not perfect, with some remaining overcoverage, but it's closer than the normal mode, and this improves colour accuracy a bit. This mode could have been better factory calibrated though, we felt, to improve grayscale and colour accuracy more. It's possible to improve it quite a lot though with some basic setting changes, and you can find a link to our best settings guide in the description below if you own this screen. LG don't provide a preset mode for working with the Adobe RGB colour space, which is a shame as the native gamut of the backlight can cover that colour space very easily as well. But you'd need to be able to clamp it to get more accurate performance and colours. If you've got a calibration tool of your own, you can do this either through normal software ICC profiling, or you could also use the hardware calibration feature and LG's Calibration Studio software, which gives you further levels of control at a hardware level. That's a pretty unique feature to LG's monitors in the consumer space at the moment, and it allows you to calibrate the screen's internal lookup table for improved levels of accuracy. This is also useful as you don't need to worry about which applications can use an ICC profile, with the calibration being carried over into all applications and uses, including for games and videos too, as it's stored in the monitor itself. Their software for this, which supports a wide range of third-party calibration devices, all sold separately, is straightforward to use, and it allows you to define your targets for color gamut, gamma, brightness, and so on, before an automated process then basically configures everything for you. There's 2 modes in the menu that you can hardware calibrate if you want to different targets and standards, and it's great to see this feature on offer from this monitor. We also calibrated the screen in the normal way in the native mode, which produced excellent results as you'd hope, correcting the grayscale nicely and offering very good colour accuracy for sRGB content now in colour aware applications, where the ICC profile can be used. You can find a link below to our full best settings guide, which will help you configure the screen in all areas, along with our calibrated ICC profile as well. We evaluated the SDR shadow detail performance, which is important when viewing darker content. The screen was configured to 200 nits luminance and we tested it in each mode. Because the screen has a standard IPS LCD panel and a pretty limited contrast ratio of only 1000:1, the black depth was not a strong point of this panel, and so it was hard to distinguish between the darkest grey shades in these tests. Shadow detail was rated as moderate in the native and sRGB modes, and it's worse in the DCI-P3 modes because that's configured to a 2.6 gamma instead of 2.2, which causes that change there. There is a black stabilizer setting available in the menu, which can be raised from the default 50 all the way up to a setting of 100 if you want. The good news is that none of these settings cause the black point to be raised at all. They just alter the luminance of darker grey and mid-grey shades to varying levels. We've plotted the results for several options to demonstrate how it raises the luminance of different shades, improving the darkest shades a little as you move up through the levels. You can experiment with this to find a level that suits for darker content if needed, but somewhere around 70 feels like a sensible balance if you want to use it. The screen is really well suited to office and general applications as well as professional usage. The 5K resolution on a 27-inch screen size provides an amazing image quality with a 218 ppi pixel density and, as Apple would call it, a Retina class resolution. 27-inch 4K resolution screens are already really sharp and crisp, and not everyone is necessarily going to see the benefit moving to 5K, but in side-by-side comparisons, it does look even sharper and more detailed. 1K difference might not sound a lot, but there's actually 78% more pixels than there are on a 4K screen and 34% higher pixel density as well, and it does make a difference in practice. Some people are going to say that they'd like 5K on a bigger screen like 32 inches for instance, but actually if you want to retain the same Retina class pixel density on a larger 32-inch screen, you need the resolution to be bumped up to 6K. 5K is very well suited to the 27-inch screen size and it's becoming increasingly common at the moment. You will of course need to use OS scaling to make text a sensible and comfortable size. 200% is what Windows recommends for this physical panel resolution, and that will give you the equivalent desktop area as a normal 1440p resolution on a 27-inch screen size, just with the double pixel density on offer for a much sharper and clearer image. 175% scaling is very usable as well and will give you a nice boost in desktop area compared with a typical 1440p monitor, while running at 150% scaling would have a similar small font size to something like a 32-inch 4K monitor if you were using that without any scaling. Some people might find that okay as well. You've got plenty of flexibility here anyway to run at lower scaling factors when you want to and if you find that comfortable. But the 5K resolution is really all about offering a super high pixel density so that everything is just really sharp and crisp. A 5K resolution is considered important as well from Apple Mac users, where 5K is recognised by macOS as a Retina resolution on a screen this size, whereas common 4K resolutions are not. And you can also then use 4:1 integer scaling to scale from 5K down to 1440p equivalent, which is considered to offer better performance and a sharper image than trying to scale 4K to 1440p on Mac systems. Of course, being an LCD panel, you don't have the concerns around image retention and burn-in that you might have on an OLED screen as well, making it much more suited to extended periods of static content and general applications. You may have seen some early reports of a text sharpness bug from some early owners of the screen, where the right-hand side of the screen looks more jagged than the left-hand side, with text and other apps looking a little bit more jagged and less clear. This bug has thankfully been quickly resolved by LG, and a firmware update is now available that fixes that, and you'll see it prominently promoted on their product page as well. Make sure you've updated to the latest firmware if you buy this screen, as that issue is now resolved. We found firmware updates to be fairly quick and easy through LG's Switch app, by the way. The panel has a light matte anti-glare coating like other modern IPS type panels, providing good reflection and glare handling in brighter room conditions. Some people may be looking for a glossy coating instead, and there are a few 5K dual mode monitors being released later this year with a glossy finish. But this coating used here will be more suitable for some people, especially in brighter rooms where you have light sources in front of the screen and so on. Panel uniformity was moderate on our sample, with the sides of the screen dropping in luminance a fair amount compared with the central area. This didn't present any issues in general and dynamic content, but if you're working with large blocks of colours in photo editing applications, for instance, you may want something a little bit more uniform. Results could of course vary between samples too, we should keep in mind. In terms of usage scenarios, a 5K display is great for video editors and post-production professionals when working with 4K content, because you can view all of the content at the true native 4K resolution and still have a fair amount of leftover screen space around it for UI elements and controls and that kind of thing. That could be important for 4K content creation and video production, and it's also great for photographers who want to view and edit their images in amazing detail. It's also great for any kind of 3D modelling or design work which needs high detail and high resolution, or for graphic designers who might want an expanded workspace. I can already feel people itching to leave a comment below if you haven't done so already, saying, but 5K is going to be really hard to power for games. We'll come back to gaming use cases in a moment, hang on. There's a broad set of connectivity on the screen, which includes USB Type-C with 90 watts power delivery, which could be useful for connecting laptops and other external devices. There's HDMI 2.1 for consoles and external media devices, and there's also DisplayPort 2.1 with UHBR20 speeds for PCs, which is great to see. Although for 5K 165Hz at 10-bit, you still need to use DSC to reach that bandwidth, and that could have then been achieved with UHBR10. From a DP 2.1 system and using a DP 2.1 cable, we found that the screen ran at UHBR 13.5 mode with DSC being used. We also tested the screen from an older RTX 30 series GPU, which only has DP 1.4 connectivity, and we found that it could still support the full spec 5K 165Hz and 10-bit, and also the dual mode 330Hz at 1440p. While the bandwidth requirements might normally be just outside the capacity for DP 1.4 with DSC, this does depend on display timings, and it looks like those have been optimized here to allow the screen to run at full spec even from older graphics cards. That's great news of course for anyone with an older system. You'll certainly need to make sure that your graphics card supports DSC, and results could perhaps vary depending on different graphics cards and different systems. Ideally, of course, you'd want a modern DP 2.1 capable graphics card, but it's good to see that you're not capped to a lower spec if you've only got a DP 1.4 with DSC available. There's also a couple of USB-A data ports and a headphone connection, but unfortunately there's no KVM switch function or picture-in-picture or picture-by-picture support for some reason. Those seem like odd omissions really on a screen of this spec and price, and some people might find that a bit of a shame and be disappointed that they're not available. The built-in speakers are decent and provide good sound support, and that's something that's not often found on competing screens in this space. The AI sound feature actually works pretty well at providing a more immersive experience, we found, creating more of a simulated surround sound experience, which you could definitely notice when switching between the off and the on modes. It sounds less flat and it works nicely. The bass boost mode also helps improve the sound a bit further, we felt. The stand offers a full range of tilt, height, swivel and rotate adjustments, which are all smooth, but they are quite stiff to operate, especially the height and rotate functions, which seemed really stiff on our unit. The screen feels well built and sturdy, with a metal foot providing a solid base for the pretty heavy screen, although there's still some moderate wobble as you move it around and you use the on-screen controls. The on-screen menu is accessed via a single joystick toggle on the back, which provides quick and simple access around the menu. There's a decent range of settings available, and there's also a quick switch button on the bottom edge of the screen to activate dual mode, which is handy to have available. You can install the LG Switch app for some additional PC-based controls, including support for firmware updates where needed. The design is simple and professional looking, with thin borders, a dark grey rear enclosure and a dark grey metal foot, although the foot is quite large. There is an RGB lighting feature on the back for those who like that kind of thing too, but the overall design is more professional and less gamery. There is a small built-in fan in the screen like we've seen in other recent LG monitors that we've tested across their range. If you've got a silent system and a quiet room, you may notice this in action, especially if it ramps up during HDR usage or bright content, and it seems to be a bit more noticeable than on their OLED screens that we've tested recently, where it's very hard to detect. Although that's probably because this is a smaller screen size here compared with those larger 39-inch and 45-inch OLED monitors that we've tested, with the fan needing to do a bit more cooling due to the smaller design. This screen provides an interesting choice for gamers, and it's part of a new wave of 5K dual mode monitors that we're seeing launch to market. On the one hand, you could potentially use the screen in its native mode, with a 5K resolution providing a high resolution and pixel density for a super sharp image in graphically focused games. There's a 165Hz native refresh rate as well, so that's still good, but the main challenge with gaming in 5K mode will be the power needed from your system to push any reasonable frame rates. The 5K mode is more aimed at general and desktop applications, professional and productivity uses, and so on, and we've already discussed what an impressive picture quality it can offer in those uses. For gaming, 5K is probably only going to be suitable for slower paced titles and more casual gaming because of the system demands of such a high resolution. This is where people seem to immediately jump though to objections about how it's going to be so hard to power 5K for gaming and reach those kind of frame rates, but we think this is a pretty limited view. You don't have to play games at 5K. You could of course lower your in-game resolution, play at lower settings, or use technologies like NVIDIA DLSS from lower resolutions while improving your frame rates at the same time. You're not locked to only using 5K for everything, but at least that option is there for usage away from gaming when you want it, where it offers significant benefits. Probably more relevant for gaming though will be the dual mode function, offering you the ability to double your refresh rate to 330Hz when reducing your resolution by a quarter. That's common for these dual mode functions, but the important difference here is that by having a 5K native resolution, when you use dual mode, it's only dropping to 1440p. On a 27-inch screen like this, that's still a very usable and normal resolution. It's a much better option than typical 32-inch 4K monitors that we've seen, which have to drop to 1080p, and that leaves you with a very low resolution on those larger screens. 1440p on a 27-inch is still very decent. Dual mode is accessed via a quick access button on the bottom edge of the screen and takes a couple of seconds to switch over to the new signal. You can also access it via the main menu, where there's also an option to simulate a smaller 24.5 screen size if you want to. That adds black borders around the sides of the image, and if you use the 24.5-inch mode in the native 5K operation, the screen then gives you 1:1 pixel mapping, but leaves you with a still very high resolution to power. In dual mode, the 24.5-inch simulation continues to operate at 1440p natively, which squashes that resolution into a smaller screen area, but that 24.5-inch simulated size is likely to be more aimed at people who want to use a lower resolution, perhaps something like 1080p, although that won't be with 1:1 pixel mapping of course. Like we've seen on all of the dual mode monitors that we've tested to date, dual mode does not offer pixel perfect integer scaling, and so there is some slight softening of the 1440p image as a result. Although given the resolution remains decent for a 27-inch screen size, it still looks very good overall, and it shouldn't present any issues in dynamic content and gaming. Sure, you can definitely see the drop in sharpness and picture quality compared with 5K mode, that's unavoidable, but we thought 1440p looked very good. That means then for faster paced gaming, you've got a much lower resolution to contend with, allowing you to push for higher frame rates and make use of the extended refresh rate range that this mode offers you. It's not the big sacrifice in resolution and density that we've seen on some other dual mode monitors in the past, and we think this starts to make it a far more interesting option for most people. The screen uses adaptive sync to support variable refresh rates with certifications for VRR performance, under the 3 key schemes shown here. There is a setting in the menu for 2 adaptive sync modes. The extended mode is the default, and that offers a VRR range of 48 to 165 Hz or 48 to 330 Hz when using dual mode. The standard mode offers a slightly shorter VRR range down to 60 Hz minimum. Below the bottom end, LFC is used in both modes. Being an LCD screen, we saw no issues with VRR flicker even during stress testing. There's a typical range of gaming settings and extras on this screen, with the most notable being the support for a dual mode function. There's also a blur reduction mode offered on this screen, which we'll take a look at shortly, along with the AI gaming features as well. When it comes to panel response times, there's 4 modes available in the on-screen menu to control the overdrive level. We measured the response times in each mode in the native 5K 165Hz configuration first of all. There's small improvements in grey to grey speeds as you move up from the off mode to the normal mode without introducing any overshoot at all, and then another small improvement as you move up to the fast mode, all without any visible overshoot in practice, although a little bit is now starting to appear in some of our measurements. Visually, those 3 modes all look very similar though, with the fast mode offering some small improvements. The faster mode pushes the response times even further, but overshoot starts to reach higher levels. Not actually terrible in practice, but you can pick out some pale halos. With the fast mode providing the optimal performance, we measured the performance then during VRR situations as well. The screen does not offer a variable overdrive feature, and so with grey to grey speeds remaining pretty consistent across the VRR range, the overshoot levels start to creep up a bit at the lower end of the refresh rate range. It never reaches problematic levels and remains very reasonable in practice, and so you still have a single overdrive mode experience on the screen for the 5K native mode, which is great news. Ultimately, that's what matters anyway with response times. In dual mode operation, the response times again remain consistent, but overshoot reduces at the higher refresh rate. The problem with this mode is that the grey to grey transitions aren't really now fast enough to keep up with the higher frame rates, and we had poor refresh rate compliance. You could maybe move up to the faster response time mode, which improves the grey to grey speeds at the cost of a bit of overshoot, but in practice it doesn't look much different or provide much better experience visually, and then you just run the risk of higher overshoot as the frame rate's lower. As such, we'd probably stick with the fast mode even in dual mode operation, and it's a shame that the response times weren't a little bit faster at the top end of the refresh rate range. The challenge without variable overdrive control though is that had they pushed the response time faster in those higher refresh rates to improve the smearing and reduce the blurring a little bit, it would have resulted in more overshoot then at the lower end of the refresh rate range. So on balance, the approach that they've taken is probably preferable anyway. Motion clarity is improved in dual mode operation thanks to the increased refresh rate, as you'd expect. And for an IPS LCD panel, the performance was decent and the screen felt much snappier as well. You can see a little bit of smearing creeping in along the black edges here, where the response times are struggling to keep up, but the image was still sharper and clearer in this dual mode. LG provide a motion blur reduction mode in the menu as well, although you first have to disable adaptive sync as it only functions at fixed refresh rates. We also found that it only works when running the screen in native 5K mode at refresh rates of 120, 144 and 165 Hz. It doesn't operate for 60 Hz inputs, and it cannot be enabled for some reason in dual mode either. In dual mode, adaptive sync is locked and cannot be disabled from the screen menu, so you cannot use blur reduction mode there, which is a bit of a shame. In native 5K mode, it's a simple and quick on-off toggle. The screen doesn't turn black or change signals or anything, it just instantly activates a strobing mode which strobes the backlight in sync with the refresh rate of the screen. It does a nice job of making moving content sharper and easier to track, and it starts to bring out finer details too, as you can see from the text sections in these pursuit camera photos. The image looks noticeably sharper, although there's a small amount of strobe crosstalk ghosting visible behind the moving UFO. This actually remains consistent across all areas of the screen. It's the same at the top as it is at the bottom of the screen. This mode is especially useful then for lower refresh rate situations to improve motion clarity nicely. You can use this mode in both SDR and HDR operation, and even with the local dimming backlight enabled, which seems to reduce the visible crosstalk a bit as well, making that a great combination for gaming if you want to maximize motion clarity and contrast together. One annoyance is that while you can change the brightness setting in this mode, this is not remembered independently between the off and the on modes. So you may find you have to change the brightness slider when you enable blur reduction mode if you want a brighter setup for gaming, and then change it back, of course, when you turn it back off. The screen can reach an incredibly high 706 nits maximum brightness, even in blur reduction mode, which is extremely impressive, and gives you a huge adjustment range to play with depending on your gaming preferences. This is actually the brightest blur reduction mode we've seen to date, in fact. Input lag is very low in all modes, and once we've accounted for a small element of pixel response times in the figure, there is less than 1 millisecond of lag in the native 165Hz and in the dual mode 330Hz operation. Even lower refresh rates for fixed input devices like 60Hz and 120Hz remain very low, which is great news. This screen also includes their AI Upscaling feature that we first saw on their 39-inch OLED monitor earlier in the year, designed to improve the sharpness and image detail on low resolution content. We won't repeat all of the analysis and findings from that review here, but for PC input sources, this function isn't of much value, although it does function in a few more configurations on this screen than it had on the 39-inch OLED. The challenge, as before, is that regardless of what you set your resolution to in Windows, the active signal resolution can vary, and it's that active signal resolution that dictates whether the AI upscaling feature can work or not. If you were to set your game to a low resolution, there's a few scenarios where the active signal is reported correctly and where the AI upscaling can then make a difference, as shown here in green. But in other situations, the selected resolution just ends up being reported differently to the screen, and AI upscaling either doesn't work or doesn't offer much benefit. The main scenario where you might have potentially want to use this is in dual mode operation, where you could have used a lower 1440p resolution and then used it to upscale back to 5K like levels. But unfortunately, it doesn't work at all in dual mode through our testing. The same situation that we'd seen on the 39-inch OLED monitor as well. But with technologies like DLSS available, those will handle low resolution upscaling better anyway. And so for PC gaming, you're unlikely to use the built-in feature as much, although if you did want to, there's a few more scenarios where it can make a bit of a difference here on this model. Where it does become more useful though is for external devices like Blu-ray players, games consoles and media devices, where the source signal is detected properly by the screen, and that allows the upscaling feature to function more readily. We tested this with an Xbox Series X, for instance, and with the native resolution of the panel now being 5K, this function even works when you input a 4K signal, offering some small improvements in sharpness and image detail. This offers more substantial improvements than if you input a 1440p resolution, and then even more improvements again if you drop down to a 1080p resolution. The lower the resolution, the more benefit the AI upscaling can offer relative to the standard operation. For modern consoles, if you're playing games that support the higher 120Hz refresh rate and your game resolution ends up lower when you're using things like performance mode, for instance, on a PS5, you'll see significant improvements with the AI upscaling feature. It's definitely more useful for external devices rather than PC gaming, and for older generation consoles, Blu-ray players and the likes, which can typically run at 1080p and 60Hz, and there's some significant improvements when you're using it in those instances. Console support was very good, including support for 4K 120Hz signals, VRR and high-end HDR experience thanks to the mini LED backlight. That can also be used in SDR gaming to improve contrast significantly. There's a useful blur reduction mode which can run at 120Hz on the screen, which could be useful for boosting motion clarity further for consoles, and there are some good integrated speakers which provide nice support for external devices like this. The 2.7 GM950B is a very impressive screen with a great spec and panel. The upgrade to 5K resolution from common 4K screens of this size makes a difference in several ways, including offering even sharper and clearer text for office and professional applications, and bringing with it Retina class pixel density and better support for Mac users too. The key benefit though of the 5K resolution is that a dual mode function used to double your refresh rate to a high 330Hz here actually offers a more practical and enjoyable resolution at 1440p than 1080p would from a 4K resolution screen. Only by having 5K native does that open up this option for 1440p dual mode, which looks very good for gaming on a screen this size. And it starts to make dual mode functions far more interesting, we think. The mini LED backlight also performs very well, and although it doesn't reach as bright as some other mini LED monitors that we've tested, 1000 nits is still very good, and the local dimming and zero optical distance panel offers improved contrast, better blacks and reduced halos and blooming, which was really good news. It's missing a couple of features like a KVM switch, picture-in-picture and picture-by-picture support. Some people might be disappointed with the lack of some of those features, but on the other hand, there's good connectivity, some decent integrated speakers, and some AI upscaling features that provide some useful additions in some uses. The 27GM950B is available to order now in many regions, and you can check latest pricing and availability for your region using our affiliate link listed below. If you've enjoyed this video, please give us a quick like below, that would be really appreciated. And do let us know in the comments section below if you own this screen, if you're thinking of buying this screen, or perhaps if you've got your eye on another 5K dual mode monitor that's being released later this year. Anyway, thank you for watching. We'll catch you next time.